Hey, Math Tutor here. These are step-by-step explanations. I'm going to show you exactly how to write your answers. So this is polar area. So the way polar area works is you have to take your function, which in this case is just that. I'll use purple. And because that's the function they gave us, right? And then you have to square it. And then you have to multiply it by a half, and then you integrate it. And you can write the half on the outside of the integral because it's just a constant multiple. The bounds are from 0 to pi. So the question literally says 0 to pi, but here's the reason why. Because the boundary, if you think of it as an angle, is like 0 radians. And then here's the other boundary, and that's pi radians. Okay, so you put that in your calculator and you get this as your answer, round it to 3 decimal places. There you go. By the way, this is an integral you do have to do on your calculator because like they don't teach you how to do integrals like this by hand in this class. It's just beyond the scope of this class. It requires integration techniques that are too advanced and like trig identities and all this stuff. So here's how I would actually write my answer, like literally on the AP exam. So notice I just wrote r of theta, right? Like, because that is literally like the nickname for that function. So I can just call it by its nickname. Cool. All right, on the part B. So now we have to find dx d theta. So, okay, so I know that there is a formula for the slope of a tangent line, which is dy dx. That formula is like this for polar and for parametric. For parametric, though, you wouldn't have thetas, right? You would have like t's. But all right, so this is the formula. So they told me what dy dx is. They told me what the slope of the tangent line is. It's negative 3 over 7, so plug that in. They told me what dy d theta is. 3 square root 2 over 2, so plug that in. And I just need to solve for dx d theta. It's like an algebra problem. And so you do that. Negative 7 root 2 over 2 is the answer, I guess. But remember, you don't have to simplify your answers. You can literally just leave your answer like that. And this is how I would write my answer. Yeah, you don't have to simplify your answers. Okay, on the part C. Now in part C, you do have to find a critical point. So a critical point is where the derivative is 0 or undefined. And interestingly, they actually gave us the derivative. It can be shown that that's the derivative. Yeah, you could show that, right? Like they gave you the original function, you could calculate the derivative. So they kind of like did part of the problem for us, which is, I think, interesting. Sometimes they do that on these FRQs. So, all right, we need to set this equal to 0, figure out where the derivative is 0 and where the derivative is undefined. Turns out this derivative is never undefined, so actually don't worry about that. But it is 0 at this spot. Now, did I solve that by hand? No, I did not. I solved it with my calculator. You can solve any equation with your calculator, with your graphing calculator, or with Desmos, right? So here's literally a screenshot of Desmos. So the way you solve equations with your calculator, right, is you do y equals each side of the equation, and then you get like two lines or like a curve and a line, whatever, and you see where they intersect. So in our case, we graph them and we see this is the intersection point, right? And so that's the x value or theta value that we're looking for. There are plenty of other intersection points as well, but those fall outside of the interval, right? That was the interval we're working in. So that's the only answer, 0.553. By the way, notice I wrote 553. I mean, you could also write 554, right? If you actually were rounding it, you would write 554, right? But on the exam, you can always round down if you want to. Like, you will get full credit for writing 553. And here's my answer. Okay, cool. And then for the second part, we have to use a derivative test. So we're going to use the first derivative test. You could use the second derivative test as well, but let's just use the first one. It's probably easier. So the way this works is if it switches, the derivative switches from plus to minus, that's a relative max. If the derivative switches from minus to plus, that's a relative min, right? So in our case, it's a relative max because r prime literally switches from plus to minus at the critical point. And how do I know that? Just from looking at the graph. So like literally here is plus because literally like the y coordinate is positive, right? Meanwhile down here it's negative because the y coordinate is negative. So the purple curve literally switches from plus to minus at this point. So that means, according to the first derivative test, it is a relative maximum. And so here's how I would write my answer. Yep. It's the same sentence that was written here. Now, I should mention this. A lot of people will want to like draw like a, what do you call this? A sign chart, or I guess it's just a number line. And then they have the critical point listed here, which was 0.553. Okay, so 553, not 533. I almost wrote the wrong thing. So this though is not like the College Board is not okay with this. Like you can write this, but this will not get you, this will not count as an explanation. And it might sound weird that like, why aren't they okay with sign charts? But this has been their policy for like 20 years now. And I agree, it is kind of weird. But so when they ask you to explain your answer, and actually they don't ask you to explain your answer here. They don't explicitly say that, but I'm guessing that's what they want you to do because that's generally how these types of questions work. When they want you to explain your answer, like this is not an explanation. An explanation is like an actual like sentence with like English words or math symbols maybe, but like it needs to be an actual sentence. So that's why you need to write this. And I do use math symbols in here like plus or minus to mean positive and negative. You can do that and still get full credit. I even abbreviate some of the words here. You can do that and still get full credit. But the point is you have to write like an actual sentence. Okay, so you can write a sign chart if you want to. It's not like illegal or something. It's just you will be writing it for yourself. I even heard an AP Calculus expert say that the graders are forbidden from reading your sign charts. Like literally, that was his word, forbidden. So seriously, if you draw a sign chart, you're just drawing it for yourself. And then in part D, okay, they ask for the average distance. So there's a formula for average value. It's this formula here, right? And so that's what we're going to use, right? We're going to use it on R, because R is distance from the origin to a point on the polar curve, right? I mean, they use a bunch of words here when they could have just not used any words. They could have just called this R. It's literally the same thing as R. So you're supposed to find the average R. Let's use the average value formula, plugging in R for our function. You know, we're supposed to do it from pi over 2 to pi, so that's like A and B basically. Cool. You do that math, and here's my screenshot from Desmos. 1.726 is your answer. Once again, you could say 1.727. You can round up or round down, it doesn't matter. Here is my answer. Yep, looks like the same thing. All right, there you go. And I guess I left the pi out here. There's supposed to be a vertical line on that pi, right? Okay, so and the official solutions to this are not out yet. I mean, literally, I'm recording this on the day that they just released the FRQs. So the solutions are not out yet. So when the solutions do come out, I'll put a link to those in the description so you can compare my answers to the College Board's answers. But yeah, that's it for this video. Thanks for watching.